The robots you're about to see don't just move, they learn. They observe, adapt, and evolve with every single experience. Welcome to the era of physical AI, where artificial intelligence steps out of the computer and into the real world. For decades, we've imagined intelligent machines, but they were mostly confined to our screens. Now, that's all changing. These aren't your typical factory arms, stuck in a loop of repetitive tasks. These are thinking, learning entities. Today, we'll explore how this new generation of learning robots works, who's building them, and how they could completely redefine industries from logistics and healthcare all the way to our daily lives at home. This isn't just an upgrade. It's a revolution in what it means for a machine to be smart. We're witnessing the birth of intelligence with a body, and it's happening faster than anyone predicted. So, what exactly is physical AI? To put it simply, it's the next giant leap after the digital AI we've gotten used to, like ChatGPT. It's about giving those incredible AI brains a physical body, allowing them to interact with the world, sense their environment, and make decisions in real time. Think of it as the brilliant mind of a large language model combined with the agile body of a Boston Dynamics robot. We're seeing this come to life right now with humanoid robots from companies like Figure AI, Tesla's Optimus project, and the impressive Phoenix robot from Sanctuary AI. The key difference here is that these machines don't rely on rigid, pre-programmed motions. You don't have to write a million lines of code for every single possible action. Instead, they learn through trial and error, a process called reinforcement learning, and by watching ESA technique known as imitation learning. They learn just like we do, by observing, trying, failing, and trying again. This approach allows them to become incredibly versatile, moving beyond a single, specialized task to potentially handle almost anything a human can do. It's the difference between a tool and a true collaborator. Let's break down exactly how these robots learn, because this is where the magic truly happens. There are three main methods powering this revolution. First is imitation learning. This is where a robot literally watches a human perform a task like making a cup of coffee or sorting packages and then translates those movements into its own actions. It's like a digital apprenticeship where the robot learns by seeing. The second method is reinforcement learning. Here, the robot tries to accomplish a goal on its own. When it gets closer to the solution, it receives a positive reward in its programming. When it makes a mistake, it gets a negative one. Over thousands or even millions of trials, it fine-tunes its actions to maximize those rewards, essentially teaching itself the most efficient way to succeed. It's pure trial and error, but on a superhuman scale. And finally, the most powerful method, collaborative learning. This is where a network of robots shares its experiences. Imagine one robot in a warehouse figuring out the perfect way to pick up a tricky new type of box. Instead of that knowledge staying with just that one unit, it's instantly uploaded to a central AI model. In seconds, every other robot connected to that network gets the upgrade. A breakthrough made by one robot immediately benefits thousands, creating a kind of collective machine intelligence that learns and improves exponentially. This is how they'll go from clumsy to capable in record time. And don't be mistaken, physical AI isn't some far-off science fiction concept anymore. It's already being deployed and tested in the real world right now. In manufacturing and logistics, we're seeing robots that can adapt to new tasks on the fly without needing months of reprogramming. A new product line? No problem. The robot can learn the new assembly process in a fraction of the time it would take to retool an entire factory. In healthcare, the potential is astounding. Surgical robots are being developed that can learn hand precision and delicate movements directly from the world's best surgeons, potentially making expert-level procedures more accessible everywhere. In the service industry, AI-powered waiters and assistants are learning to respond naturally to our voices and gestures, making interactions feel less robotic and more intuitive. And perhaps, most impactfully, we're seeing the rise of adaptive robots for elder care and home assistance. These machines can learn an individual's daily routines, help with chores, and provide companionship, all while adapting to the person's specific needs safely. These systems don't just save time and money. They reduce human error and risk in environments that demand absolute precision and reliability. They are becoming the hands and feet of AI in the places we need them most. So, who are the key players racing to build this future? Leading the charge are some of the biggest and most innovative names in tech. You have Tesla with its ambitious Optimus project, aiming to deploy thousands of humanoid robots, first in its own factories and eventually in our homes. Then there's Sanctuary AI, whose robot Phoenix is demonstrating incredible fine motor skills, learning tasks that require human-like dexterity. We also have Figure AI, which recently partnered with BMW to bring its humanoids into automotive manufacturing plants. And let's not forget Agility Robotics with its bipedal robot. Digit, which is already being tested in Amazon's warehouses to work alongside human employees. Each of these companies is taking a slightly different approach, but they all share the same ultimate goal: to build the world's first, truly general-purpose robot. A machine that can learn and perform virtually any physical task, just like a human employee, but without getting tired or making mistakes. With billions of dollars in investment pouring in and major partnerships already underway, this isn't a question of if, but when. The race for the first true AI-powered workforce is officially on. But with such rapid progress, we have to pause and consider the risks. With great power comes great responsibility, and physical AI presents us with some of the most profound ethical questions of our time. How do we ensure these robots learn ethically and align with human values? What happens to society when robots can perform repetitive labor at a massive scale, potentially displacing millions of jobs? It's a question we can't afford to ignore. And what about accountability? If an AI-controlled robot makes a mistake that causes harm, say, in a medical procedure or while operating machinery, who is responsible? The owner? The manufacturer? The programmer who designed the learning algorithm? There are no easy answers. Physical AI forces us to fundamentally rethink our definitions of intelligence, labor, and autonomy in a world where machines don't just compute numbers, they act in our physical space alongside us. Navigating these challenges thoughtfully will be just as important as developing the technology itself. The robots of the future aren't just going to be our assistants. They'll be our learners, our collaborators, and in many ways, a reflection of the intelligence we give them. The line between science fiction and reality is blurring faster than ever. The question is no longer if these learning machines will become a part of our daily lives, but how quickly it will happen and how we will choose to integrate them into our society. The next decade promises to be one of the most transformative periods in human history. Thanks so much for watching. If you found this deep dive into physical AI as fascinating as I did, hit that subscribe button and turn on notifications. For more explorations into the future of technology and artificial intelligence. Because the machines are learning fast, so should we. See you in the next one.